Hi, hello. This is my first video because I'm starting a new series on statistics, and I want to have a video series where I cover all the fundamentals. You know, I just want to explain because sometimes statistics can be scary to some few, but I want to go in depth and explain it the way that you can grasp the concept and understand what it means. So without further ado, let's talk about regression analysis. So to explain regression helps you answer questions like, does studying increase exam score, or does advertising increase sales, or does AI adoption improve firm performance? So the whole idea is to show whether a relationship exists or how strong is the relationship or the direction of the relationship, positive or negative. So every day we use regression. So imagine you want to know if drinking more coffee helps you work longer hours. What are you gonna do? You collect data on coffee, cups of coffee that you drink, and you also collect data of how many hours you worked. So regression help you see if coffee is linked to more hours. So then it also can help you see how much extra work time each cups each cup of coffee adds. So a typical example can be each extra cup of coffee is linked to 30 minutes of work. So that is regression. So in one sentence, regression is a tool that helps you predict or explain an outcome based on other factors. So, to understand regression, you have to understand the idea of dependent versus independent variable. So, the independent variable, the IV, this is more like the cause or the thing you think influence something. This is more like the thing that influences something. It is also what you change, compare, or use to predict. It is also called the predictor or the explanatory variable. For example, might be hours of study, hours studied, amount of advertising, level of AI use in the firm, training hours for employees. Then the dependent variable, which is the endogenous variable, is the outcome, the result or outcome you want to explain. So it depends on the dependent variable depends on the independent variable. Like it's also called an outcome variable or the response variable. Example can be exam score, sales revenue, firm productivity, and employee performance. So in a simple way to understand this, independent is input, dependent is the output. So everyday example can be, let's think about studying. Now the independent variable is hours studied, and the dependent variable is exam score. Let's talk about a business example. Independent variable is advertising spent, and the dependent variable is sales. So let's so it's almost like if you ask a quick test, does X affect Y? X is the independent variable, while Y is the dependent variable. So This is it, the dependent variable, endogenous, response, and outcome variable. Why the independent variable, the predictor, explanatory, or the exogenous variable? So a simple regression equation is this. Y is the dependent variable. And you can see there's an error term here. So the error term is a critical catch-all for statistical modeling. It captures everything missing from the model and represent inherent random noise. It also accounts for measurement inconsistency. So let's talk about different type of data. So number one is the continuous data. So what is this? Continuous data can take any value on a number line. It includes decimal, fraction, measured, not counted. So think like how much. Example can be height, 5.72 feet, weight, 70.5 kg, temperature, 36.60 centigrade. So it can be the GDP growth 2.7. So it takes any value on a number line, you know, it can be anything. So the integer data, what is it? They are whole numbers only, no decimal, usually counted. Example is number of students, number of papers published, number of students can be 45, that's whole numbers. Number of papers published can be 3, number of cars in the garage can be 10, number of children in the family can be 2. So whatever it is, binary data, can be only two possible values, zeros and one, or yes or no. Uh, you know, it can be only zeros and one. Smoking, do you smoke? Yes or no. Subscription, yes or no. Zero, yes, one means one, zero means no. Ordinal data is are more like categories with clear order, but the distance between rank is unknown. Let's say ordinal data can be like a Likert scale where you say strongly disagree, strongly agree, neutral agree, that's ordinal data that you use for survey Likert scale. So nominal data is categories with no order, just labels. It can be mode of transportation, that's car, bus, bike, train, nationality, Nigeria, America, Canada. So these are just examples of nominal data. So this mathematical model and software cannot work with strings. Computer requires numbers for matrix algebra. Alright, so common in regression common in regression to linearize relationship to normalize variance. For example, taking a log of y fundamentally shifts the model. This changes the interception of the coefficients. So basically, what I'm trying to say here that sometimes in regression we need to transform variables using logs to make the relationship cleaner and easier to model. So the common reason is that to make uh, to make curved relationship more straight, linearized, reduce unequal spread in data, normalize variance. So so instead of just using y directly, you can use the log of y in the regression. So instead of using so why do this? You can to strengthen the curve relationship because real life data is often curved And example, early years of education may raise income a lot, and later years raises it less. That curve can be hard for regression. So taking log often makes it look like a straight line. So that's the whole point. So that's the end.